And now is to talk about the Pearson correlation coefficient, which is denoted as R. And the purpose of this is to calculate the linear relationship between two variables. So the relationship value of the coefficient is between -1 and 1, where 1 indicates perfect positive linear relationship. When one gets bigger, the other gets bigger as well. R equals -1 indicates negative linear relationship. When one gets bigger, the other gets smaller, and R equals 0 indicates there is no relationship. The formula for the Pearson coefficient of correlation is this. When you look at this formula, you can see here at the denominator that it looks like the covariance between x and y. If you remember, the covariance of two variables x and y looks exactly like this, but we have the denominator n, the number of data points, and the covariance tells us how much the two variables change together. If one gets bigger, the other gets bigger in the same manner as we said for the Pearson, but it's not between 1 and -1. So in the denominator, what you can see here are the uh, uh, standard deviations, right? So you can see here the multiplication of something like the standard deviations between the two variables. So it's like the covariance divided by the multiplication of the standard deviations. So again, it talks about the linear relationship between two variables. So for example, if we have an example of hour of studies and the test score, and those are the values. If he studied 4 hours, he got 60. If he studied 6 hours, he got 80. And as you can see, as he studied more, the score is higher. So of course, there is a positive linear relationship, and we expect to have a very positive to the one value Pearson correlation coefficient. When we calculate the means of x, the Howard studies is x, and the y, the total test scores are y, we get this, and then we can calculate all those calculations. As you can see here, we did it, and where we are calculating the numerator and the denominator of this are a Pearson coefficient of correlation, we get 1. As we expected, there is a very positive linear, maybe complete linear relationship. We can also do it in Python, use the NP core coefficient to calculate the Pearson correlation coefficient between two uh, data sets, and you can see the Pearson correlation coefficient is, as we got, is 1. Okay, so the Pearson correlation coefficient states how two variables relate each other in the sense of linear relationship. It's like the covariance divided by the multiplication of the standard deviations, something like this. And those are the values, and this is the formula. And this is an example. And don't forget the covariance, variance, and standard deviation of variables. That's it. That's about a simple example and simple explanation about the Pearson correlation coefficient. Thank you very much. Thank you, DeepSeek, for the nice writing. If there are any correction or mistakes, please correct me, and that's it.